Okay, today I'm going to take a break from my usual, or at least as of late, working on writing and see if I can get going on some scripting in Blender. So for this, I am going to be using the repository that I'm putting in the chat, which is just a repository of scripts in, oh geez, it wants me to log in. What? All right, I will do that. I'll be using a repository on my account that has some scripts in it, at least as a starting point. Um, and I'm going to attempt to get some data in directly from some scientific visualization software. So for this, well, I guess this will be using it as scientific visualization. For this, what I'm going to do is use a set of tools called, I think this one's called Node Tree scripts. It's a fork of geometry node. Um, Let me put that in here. Yeah, Node Tree script is the name. And what this does is it allows you to create geometry nodes as well as material nodes and other types of nodes from a common scripting environment. So let me show what that looks like. And I should also note, like at the very outset, um, I know a fair bit about Python programming, about visualization and so on, but I'm really not an expert when it comes to Blender. And so a lot of this is going to be me attempting to work my way through and mash up what I do know about those other domains with how to do this stuff inside Blender. So some of this is just going to be Matt mumbling angrily at Blender, and some of it's going to be really fun. Okay, let me go ahead and switch over to the coding view. Oh, looks like my camera is strange again. Let me fix that. Every time I load this up, my camera goes a little bit weird and wonky. I don't really know what's going on with Blender here. So, or with OBS when it does this, but anyhow, um, it's not really as red as it looks here. Let me see, maybe if I turn on the lights, the white balance will get better. But then you unfortunately have to see all the stuff going on in my room, in this room up here. Okay, so this is the Blender interface. I'm actually going to create a new default file, and this is just blank, and I'll get to saving it later. But what I'm going to be using is I'm going to be using this interface. So this uses what's called Node Tree script. I put the link for that inside the chat, but it's at alpha-dito/nodetree_script in the in GitHub. Oh, let me see if I can play music this time. All right, there we go. Now I'm listening to something good. And what this does is it allows you to construct a variety of nodes inside the node geometry just by developing these functions. So for example, here what I've done is I've written an ns_tree outward sphere. So that means name the contents of this function, outward sphere, and then inside it I create geometry script UV sphere, so that's the UV sphere node. I supply a couple values to it, and then I construct points where the input is the mesh output from that sphere. I create a line where I set from GS mesh_line. I set a rotation to the vector with the GS position, and then I return a collection of nodes, or rather a set of outputs. Those outputs are a geometry and points. So now here what I'm going to do is I'm going to go to geometry nodes. And so the default view for this includes the full tree structure down here. And then over here, by default, it shows you your spreadsheet. Now you can do really cool stuff here, and I'm going to select cube. And if I were to do this, I could do some really rad stuff here, like here, instead of the cube, here I'll create a operation. Here, actually, let me just do mesh primitives, and I'll do a cone. And so here, instead of having the geometry from the group input go there, I'm just going to have it output a cone. Now, there are some things about this that I don't totally understand. Like for instance, I don't know why you can't get rid of this group input. Like there's a bunch of stuff in this that's just the way that it's done that I need to think about and learn. But what I'm going to do is I'm going to change this view to text editor. You'll see up here it says geometry script. And you can get all these different documentations open, and we'll see that in a minute. But I'm going to go here to my BlendYT repository. I'm going to open up the script that I had. Now, the last time I did this, I had to specify this as like live or something like that. Does that do it? And what that should do is it should change the script every time I save it here. Let's see if that does it. So I'm going to save it. Nope, it does not. Make text internal. Is that what I want? When external text is out of sync, resolve the conflict, or yeah, there we go. File reloaded. Okay, so now let's see if I undo that. Does it? No. There's a way to make it do that by default. Make internal. Is that it? Oh no, I don't want to make it internal. I want the opposite. Here, let me close this down. Open. Yeah, well, I guess there's... Yeah, I'll figure it out eventually. But now, if I run this, it's going to create an outward sphere node and a sphere to curves, or graph, and a sphere to curves graph. It looks like it might have, at one point, I might have started doing like this max points. But let's take a look at what that looks like. So I run it, and now you'll see here, I've got outward sphere and sphere to curves, but more importantly, I can do add group outward sphere. So now I'll create this node, move my group output there, and I'll get rid of this. And so now outward sphere, geometry, drag it over to geometry. And you'll see now the results of outward sphere are output here. Now if I go here, edit group, we can see this is everything that's inside that group. So here, this is everything that was inside my script. So as an example, sphere, GS UV sphere, that's this right here. Radius 100, segments 1024, rings 1024. Points, GS distribute points on faces. You got your density, so that shows up right there. Then I create a line. Where's line? There's line. So I create a mesh line. It's got the density and all that. Wait, is that the... Nope, that's this. This is the line. Oh no, that's right. Yeah, that's exactly what it is. So there are no arguments that I supply there. But then I feed that into instance on points. The points are the points distributed on the faces. Oh, it looks like my music shut off again. Why would it do that? Yeah. All right. Seems to think that I was playing it on a different device, but to my knowledge, I am not. Anyhow, now I've got these points. I'm distributing the points on the face of that sphere. I'm aligning the rotation vector here such with the position of the points. And so what that means is that I've got everything, all the rotation vectors will be the same as the outward facing points. So they're all pointing directly outward. And then I am instancing. So that's here, GS instance on points. Instance is right there. The instance is a line, and the rotation is rotation. The points that we instance on are the output named points from this object. And that's important because here, this is distribute points on faces, and it has multiple outputs available to it. If I go over here, I've got type hinting set up. You can see, let's see, what are some of the other outputs? There's normal, and so on. Oh, it looks like it's not actually pulling that up. So here, let's try this. gs.distribute points on faces. Does that come up with anything? No. I guess here some of these, no, it doesn't have anything there either. Well, so we've got that. Okay. So now I've also got a sphere to curves. So let's make this invisible. Now, can I make a new object here without... Can I duplicate this? Anyway, like I said, there's a whole bunch of stuff here that I don't totally know how to do in Blender, but maybe there's a way to do this. Just create a new cube or something like that. No, I don't want a new collection. I want a new data block or something. Like I said, I'm still learning this. So let's go back here. We'll re-enable this. We'll just add a new cube. Let's rename this. So this will be our sphere curve. And so here we'll go into our geometry nodes. And let me disable this. These are our outward facing vectors. So we'll rename that. And now inside our sphere curve, we get rid of that. Keep our group output. And we will do sphere to curves here. Every single time it switches songs, it seems to think that I want it to let me know that I'm using it on a different device, but I know that's not true. I'm not. Okay, group output. So here, let's take a look inside our sphere to curves. We're creating two different spheres, one with a radius of 100, which you'll note is the same as this, and one with a radius of 1, segments 32, rings 32. So this one, we then create a target volume. It's a cube like that. And for points 1, I'm distributing points on the faces of my bigger sphere. For points 2, I distribute points inside the volume on my smaller volume. And I'll show you what that looks like in just a second. Actually, I can just show you right now. You can see it's way over there. This is my volume, because I set my volume all the way over here at -210, -210, all the way up to 290, so it's a box. And I distribute the spheres there. And then, check this out. I'm instancing the same sphere in both. So both of these utilize the same sphere. So any modifications I make to this sphere, sphere 2, get propagated here. So let's take a look at what that looks like. Let's go in here, edit group. Here's my smaller sphere. But if I make that bigger, you'll see that it gets applied everywhere. So that's cool. All right, now let's see what else we can do with this. So this is nice for doing what we can with it. But I am going to show you what we've got here. So I think, yep. So we've got all these different things we can do. These are the compositor scripts that I can utilize. We also have geometry that we can use, shaders, textures. And so with this, we can actually generate modules inside our scripts that we can then use outside them here. There's another key aspect of all this that I'm going to try to pull up the documentation for, which is that this can also have inputs and outputs. So this is the documentation for the previous version of it that just did the geometry, but it's still reusable in these because the underlying items are still the same. So here, also if you've never heard it, the song Party Mindset, which I am listening to right now, is just incredible. Really one of the best. Oh yeah, here we go. Yeah. Here we go. Uncheck make internal. All right. Okay. Basics, tree functions. So we've got the group output here. But we can also do group input. So this is neat. Let's convert this script to have a vector. So now where do I get the vector? Is that ns.vector? Yep. And actually we want this to be float. So here we'll change that to be size. And so now outward sphere. We rerun it. And now there should be input. So if I go back here to I'm going to disable this one, re-enable that. My outward vectors, you'll see now, includes a size. So here, as I change the size, you'll see that it's going out further. So just like that, we have set up our inputs. So one neat thing about that is we can also now specify, let's see, if I want this to be moved, no, because then we'll have to offset all of our items, but think... Yeah, we can't supply an offset, so we'll do that in a bit. Did I change something? No. So now we've got this input, and I can modify that at will. Let's also make density a float. So now we rerun this. Wish we could have an auto reload. Yeah, there we go. So now it's much, much more dense. So we can change the size, can change the density. And now let's see if we can connect these two things together. I would like sphere to curves here. We will have it output the sphere. So I think this is going to work. Can I do a sphere? Is that a real thing there? Nope, probably not. Oh, it's under GS. You know what? Let's do... We'll just do geometry there. And then we'll do sphere 1 equals sphere. All right, let's see if this works. So let's delete this. And we'll go ahead and we'll add cube. Okay. Now let's go ahead and reload this. Oh my goodness. All right, it can't express that as a node socket, so let's do this, sphere.geometry. So let's try again. Cannot express none of type none type as a node socket. Oh no. I'm not sure where exactly that's coming in, so let's take a look over here. Density ns.float. I guess it's got to be a mesh. We'll try that. No, it didn't work. Geometry node socket object has no attribute mesh. Yeah, it does. Look at right there. Oh, that's the problem. All right, let's take a look at the documentation here, because I do need to figure this out. Input groups. Do I need to have it be a full input group? Not sure. so looks like this needs to be that. Okay, let's comment that out so that we don't have the confusion there. It shouldn't generate it. Alright, so this cannot express mesh UV map of type node outputs as a node socket. Alright, so let's have it output mesh. Okay, so now that outputs a mesh. Okay, let's try a group. This will be outward sphere. Okay, so this now outputs basic geometry as well. So let's try pulling that out. And it should give us a UV sphere. And it does. Check that out. So that's the sphere on which all of these things are defined. So can we output two geometries? I guess we'll find out. Nope, it's got to be this first one. Okay, well that's interesting. So in principle, now let's see, can we take multiple geometries? Yeah, let's do that. There we go. So now we've got all of our different geometries are being displayed. And if I increase this, all of the inputs get increased as well. So that's nice. Okay. So now, let's see if we can make this come in here. We'll say sphere to curves. I think here, let's see if this works now. Now, I'm not sure because I think that, yeah, geometry node socket has no attribute mesh. So that's a geometry node socket. I need to do a little bit of figuring out what I get as input. This is it right here. Geometry. So the capture attribute, data type, geometry equals cube geo. So this geometry, I assume, is up at the top. Let's take a look. Yeah, it should be right there. Let's try GS. Nope. That should do it. So let's reload from disk. No. Geometry node socket object has no attribute mesh in spheres to curve. Oh, of course. Right there. Okay. So if we're getting it as a geometry, I don't need to do that. Now if I run it, there we go. So now I should be able to do, and let me get rid of one of those. So now we just got that. Now let me add another group. We'll call this sphere to curves. I don't remember why I even called it that. It gets a sphere as input. So we'll send the basic geometry there to that. And we'll join the geometry. And so now, that's wonderful. See, it scales. So now we've got our spheres. Let me drop the density a little bit. I'm going to have to figure out why YouTube Music doesn't want me listening to music. Okay. So basically what this lets us do is it lets us build out methods for constructing programmatically reusable nodes. So what else can we do with this? Well, one thing that I think would be interesting would be to come up with materials for them. So let's create a new material. So here, you can see we can do this with the shader. Okay. So let's see. We've got ns.tree. So let's see. We've also got ns.shader tree. Let's put this down here at the bottom. Well, that's interesting. I don't think that's actually what I want, though. Neither of these works. So import node tree script API .dynamic .shader as, we'll just call it SS. So what do we have available to us here? Looks like we've got some colors, mixes, mix RGB, normal maps, refraction. So let's take a look first at what we can do with this here. I'm going to pull it up inside my shader editor. We're going to add a new shader. It'll be principled BDSF, or BSDF. So return, that is our basic one. And we want a material output. So let's take a look at what we can do here. We'll set our base color. Now let's see, what do we have here? RGB. That's fun. There we go. Result color, color. Great. Don't have color here. Can I create a color? Let's do base color. Let's see what it takes as input. I don't think this will work, but let's take a look. Now we'll go back here to my text editor. Cannot express of type tuple as a node socket. Okay, so that, it needs a color. So let's try node sphere color. Reload. The color class cannot express that as a node socket. Ooh, that's interesting. So how do we specify colors? Well, you know what? Maybe we should make color an input. Okay, so now let's assign our material. Oh, material not available. Oh, and did I just crash Blender? No, I didn't. That's good. Did I? Oh, maybe I did. Okay, which one was I just in? Is this it? This was it. Okay, so did all this stuff cycle off? There we go. Okay. So let's take a look at my shaders and my materials. Okay. Yeah, I'm getting a lot of hangs in Blender when I do stuff with this. You know, my computer used to be top of the line. Once upon a time, maybe. Shader tree color spheres. Oh, is this not valid? Yeah, I bet that's what it is. You know what? Maybe I actually need to go all the way through to material output. So let's go back here. What is the name of what the output needs to be? Surface. And it is the what do we call that? I guess we just return. Oh no, I had it all wrong. My material uses that as a shader. So here, this will be use sphere thing, we'll call it. Delete that. We actually don't want material output here. So now there's a way to make it. Nope. How do I make a new? There's like a fancy way that all the Blender people know how to make a new view. View area. Ooh, yeah, there we go. And here I will just inside this put. Oh no, I'll move this up. There we go. And this one is going to be my text editor for quick reloading. Oh, it has no attribute. Is it all lowercase? There we go. So now add a group, color spheres. And now let's see if I can let's view it with the shader. It's going to take a sec. Let's view it fully. Hey, check that out. If I swing it around so the light is falling on it, does it look red? No, it looks like I didn't quite get it. Let me get rid of those lines so we're just seeing the spheres. Oh, but right, of course. I'm not actually assigning that material to anything. So let's pull my spheres out. We'll assign them that material. And so now this should do it. So it should be taking my color. And now if I go in here and I edit group, yeah, it did it. So here color is the wrong one. So let's go back up. How do I go back? Oh yeah, use sphere thing. Right here, they got the breadcrumbs up here. How do I go up a level in the hierarchy? That's odd. Is that it right there? Yeah, this is really taxing my computer, although I don't know why. Parent node, there we go. Okay, so let's see if we can specify our input color. Yeah. It actually is collecting the right things. So, what we've got now we have a script that generates this simple little principled BSDF with a base color that's input, and then it outputs it. Now this isn't super fancy. All it's doing is collapsing it by one level. But there's a fair number of different things we can do with this. So in theory, we can have our density input into this, as well as a fair number of other things that we input. I'm going to go ahead and go ahead and push that up. This is just my little repository of things. So now the last type of, so the other thing we can do is we can have textures generated. There's compositors. This allows for specifying things like chroma key, color balance, so on and so forth. That's neat. But I'm not really going to do a lot with compositors, I think. The other thing that we can do, though, is we can specify textures. So let's try experimenting a little bit with textures. We can have coordinates. So that's the coordinates of the texture, and it's a vector. It doesn't say how many dimensions that vector is, but let's experiment here. Let's go over here to texture. And now what I'm going to do is I'm going to delete this. And let's add a cube. This cube is going to have a texture associated with it. So we'll add, here. So where do we, let's see, material. Now which one of these? Is what we want. Well, let's go on over here to the texture node editor. Texture type. Maybe I'm just not understanding that. So let's go back here to the shader. Let's experiment a little bit with this. Let's do volume info. That's actually not what I end up wanting. I want the coordinates. So all right, let's just experiment with this. We're going to go ahead and we're going to have material output volume. So there we go. That's a volume rendering. Now let's increase our density. We can see that it's a lot higher and lower. Set our color. Well, that didn't do what I expected. I guess it's scattering in the pink. Okay. We'll just make it pretty isotropic. So why is not setting that material working for it? There it goes. All right, so now we've got the material assigned. Ideally, we would then be able to set some type of a volume information for it. So let's try this. That's volume scatter. We'll say density from the volume grid goes here into density. Okay, so that volume doesn't quite exist yet, so let's go ahead and create a volume over here. We'll create a volume cube. And there we have it. But now what we really want is we want to sample some points. So let's distribute points. That's odd. So now here we have this volume. What would be cool, and maybe this is what I should try doing. There are multiple different ways of getting data in. And I experimented with using VDB, where I found that breaking down was in my understanding of running it. Specifically, and let's see, do I have a conda environment? Let's see, nope. Let me try installing it, see what it says. It might or might not work. Just Pika. see if it'll work. But where I ran into trouble was that I tried to map AMR data in, but it didn't want to work. Or it didn't expect things the exact same way that I expected to output them. And I think that's probably a combination of me not understanding the terms that they're using and also difference in expectation about how sparse data should be stored. But let's see if we can recreate that. Now, the other thing we want to try doing here, let's see if we can come up with let's see, principled volume. This is neat. Let's see if I can do this. So let's do input. And now here, let's see if I can have some math. And if I can name that as an attribute. I'm not sure this is the exact right way to do this, but let's see if... Huh. That's interesting. It went right from Andrew WK to Goldfinger's 99 Red Balloons. That's fun. Let's go to... I'll set it to play something else right afterwards. I'll do the hives. Okay. We'll name this attribute. All right. Let's see. So how do I set an attribute? So we'll feed that value in there. Oh, no, that's not what I want. I actually want some math. Let's do just a simple sine curve. Or actually, you know what? Let's just do the position. Let's see. Attribute. Now, there's a way to... this is, like I said, I am still learning all this stuff. But there's a position attribute that I really want to grab, so let's see. I thought it was input, but it's not. So it could be geometry read position. But there, I'm worried that that's not going to be evaluating it on a field. So let's check under utilities fields. Retrieve data of other elements. Accumulate field. No. I guess let's just try geometry point. Well, here we'll do, that'll be our value. We'll have the name be density. We'll output the geometry there. This volume goes in to be the geometry there. And then we'll have this volume output there. So let's take a look at this. Let's see. So it should be reading the position and setting the value of density equal to that, but that's not necessarily what I want. I actually want just, let's do just the x coordinate or something like that. So let's take a look here. Vectors separate x, y, z. That should be doing it, but I don't think it is. Or rather, when I say should be doing it, I'm not really sure. You know what? Let's try disconnecting this stuff and seeing if just having density as an input does it. Nope. Let's do it to surface. Nope. That's probably not what I wanted. The domain on the points, I think that's probably the problem. What we really need is we need to be able to compute it on the volume. So I think that's where things are going a little bit wrong. Need to be able to specify the actual volume density, and really for that we need to be able to get the position in here, and I'm sure there's a way to do that. Let's point to the point cloud. Maybe that's it right there. Now this should give us I can't tell. And I think the problem with this is that I'm used to thinking about things much differently. I'm used to thinking about this stuff with 3D textures and whatnot. And that's certainly feasible, I'm sure, but it's not the native way of thinking about things in Blender. So teaching myself how this works is kind of tricky. That's not what I want. All right, so instead, I like to have a lot of control over the volume. So let's go back here, get rid of the named attribute. See, I feel like here volume should be able to compute the volume, but maybe that's supposed to take place inside the texture or the or the shader? The texture node is what I'm the most confused by, because here I want to be able to apply a texture. So let's set our material. I guess that's not really how they think about the volumes. So the volume material here gets into my geometry. Why is my camera way down there? Did I turn things upside? I did. I turned things all the way upside down. Wow, crazy. Okay. So ideally, I'd be able to specify a density at every point here. And that's what VDB allows me to do. Let's see. Nope, I was not able to install. Is it just called VDB in the package and PyVDB in the API? I think that's a possibility. Okay. Well, so we did get to the point of allowing the data-driven generation of the nodes. I did also set up at one point using BPy. That's not correct, actually. That was on my other machine. Here I tried to create a mesh quickly. Oh, look, there we go. 21 packages. All right, fine, whatever. Let's see if we can experiment a little bit with OpenVDB. So we should now be able to run create volume. And that should create a VDB. What? Are you serious? I thought I just installed it. Maybe now that I've got VDB installed, I need to install the Python bindings. I wonder if that'll just work. Just changing the name. Because we won't know until after it loads up. Sure didn't. Oh no, that's... Yeah, I got my VDB. Alright, so 13 megs for a galaxy. Let's create a new general. Don't save it. Oh. That's interesting. So I can import a bunch of stuff. Looks like let's go here to no, that's not what I want. Okay. Shift A. Looks like I didn't actually end up importing, or I don't have a version of Blender with VDB enabled, so, well, Anyway, I've been at this for a while. I think I'm gonna close it down now. But I did put all the stuff that I've been working on up inside my tiny little repository. And I think I'll pick this up once I'm able to get VDB working inside Blender again. Okay? Thanks for joining me.